U-Substitution integrals, part 2. In this video, we're going to integrate these 10 integrals for Calculus 1 and AP Calculus. Let's begin. Example 1. We're going to call this part of integrand u, because we have ln some number raised to the some power. So let u become 3 plus ln of 4x. Then du will be derivative of this. Derivative of 3 is 0. Derivative of ln of 4x is 1 over x. Derivative of ln of 4x using the chain rule will be 1 over 4x times derivative of inside function 4, and then 4's cancel, 1 over x. Here we're going to solve for dx. If we multiply both sides on x, we obtain x du. Now let's rewrite everything in terms of u. We have 2 here that we can pull in front of the integral sign, and instead of this parenthesis we're gonna call it u to the 1/3 power. We have x in the denominator. Instead of the x we have x du. X in the denominator and numerator cancels each other, so we're left with 2 times integral of 1/3 du. Now we have everything in terms of u. The antiderivative of u to the 1/3, we add 1, express 1 as 3 over 3, and divide it by 4 over 3, because this power is 4 over 3 altogether. We have 2 in front. Dividing anything by 4 over 3 means multiplying it by 3 over 4, and we have u to the 4 over 3. 2 and 4 simplifies to 3 over 2, and bring u back. Instead of u we have 3 plus ln of 4x and raised to the power 4 over 3 plus c. Example 2. In this integral, we're going to call this part of integrand u. Let u become negative 5 plus ln of negative 3x. Then du will be derivative of this. Derivative of negative 5 is 0. Derivative of ln of negative 3x will be 1 over negative 3x times derivative of inside function, which is negative 3. Negative 3 cancels negative 3 and 1 over x. So du is 1 over x dx, and dx will be x du. If you multiply both sides on x, you solve for dx as x times du. Now let's rewrite everything in terms of u. We have 4 on the numerator that we can pull in front of the integral sign. We have 1 over x is here. Instead of this parenthesis, we're going to call it u to the 5. And instead of the x, we have x du. X's cancel out. And if you bring u to the numerator, it's going to be u to the negative 5. And if you take the antiderivative of this, add 1, will be negative 4, and divide by negative 4. Negative 4 and 4 cancels out to negative 1, and u to the negative 4 plus c. And if you bring u back, it will be negative 5 plus ln of negative 3x raised to the negative 4 power plus c. You can either leave it in this form, or if you want, you can make it negative 1 over negative 5 plus ln of negative 3x raised to the positive 4. Example 3. In this integral, if you observe, we're gonna call this part of integrand u, so we can cancel out x terms. Let u become 3x to the third plus 4. Then du will be derivative of this, which is 9x squared dx. And if you solve for dx here, you obtain du over 9x squared. Let's rewrite everything in terms of u. Negative 18x squared, secant squared of u, and instead of the x, we have du over 9x squared. 18x squared divided by 9x squared is 2. So we have negative 2 that we pull in front of integral sign. And we have secant squared of u du. Antiderivative of secant squared of u is tangent u. So integral of secant squared of u, or secant squared of x, whichever you prefer, is tangent x plus c. So in our case we have tangent of u. If you bring back negative 2 tangent of 3x to the third plus 4 plus c. Here in this integral, you need to know this by heart. You don't need to derive or prove. Just you need to know that secant squared of x is equal to tangent x. In my other video, I have proof and derivation of secant squared of x. Example 4. In this integral, we're going to call this part of integrand u. Let u become 2x to the 4 plus 3. Then du will be derivative of this, which is 8x to the third dx. And if you solve for dx here, you obtain du over 8x cubed. If you rewrite everything in terms of u, you obtain sine of u, and instead of dx, we have du over 8x to the third. 16x to the third divided by x to the third is 2, so we have negative 2 in front of integral sign. Antiderivative of sine is negative cosine. So you can remember from here. Cosine x, negative cosine x, sine x, positive direction, negative sine x, negative direction. So if you go to clockwise, you get the derivative of each trigonometric functions. So if you go to clockwise, you get derivative. If you go to counterclockwise, you get the integral. So counterclockwise is antiderivative. So you get the integral. So integral of sine x is negative cosine x. Integral of negative cosine x is negative sine x. So here we obtain negative 2. Instead of sine u, we write negative cosine. That makes here positive. Cosine of u plus c, and bring u back to x to the 4 plus 3 plus c. Example 5. Integral of x to the 9 times e to the x to the 10 dx. Here in this integral, we're going to call the power of e as our u. So let u become x to the 10. Then du will be derivative of this, which is 10x to the 9 dx. And if you solve for dx here, you obtain du over 10x to the 9. If you rewrite everything in terms of u, we have x to the 9 here. E to the, instead of x to the 10, we're gonna write u. And instead of dx, we're going to write du over 10x to the 9. X to the 9's cancel out. And if you pull 10 in front of integral sign, it's gonna be 1 over 10. Because this is in the denominator, you pull out as in the denominator. So we have integral e to the u du. The easy part is integral of e to the u is e to the u. So here we have 1 over 10 e to the u plus c. And if you bring u back, you obtain 1 over 10 e to the x to the 10 plus c. Example 6. In this integral we have cosecant and cotangent, same angles and in multiplication form. You need to be aware that derivative of cosecant of x is equal to negative cotangent x times cosecant x. So integral of this function will give me cosecant x. So let 5x squared plus 1 be u. Then the u will be derivative of this, which is 10x dx. And the x will be du over 10x if you solve for the x here. Let's rewrite everything in terms of u. We have 50x cosecant of u, cotangent of u, and instead of the x, we have du over 10x. 50x divided by 10x is just 5. And we have cosecant of u and cotangent of u du. We said that integral of negative cotangent of x times cosecant of x is giving us cosecant of x. So antiderivative of these two functions will give us negative cosecant of x. In our case, negative cosecant of u. So if you pull negative sign in front, you obtain negative 5 times cosecant of u plus c. And if you bring u back, you obtain negative 5 cosecant of 5x squared plus 1 plus c. Example 7. If you observe the integrand, you see here secant, same angle, and tangent. Secant and tangent is in multiplication form and they have the same angle. Let's remember that derivative of secant x is secant x times tangent x. So antiderivative or integral will give us secant x. Let's call 4x squared plus 5 our u. So this is our u. Then derivative will be 4x squared 8x dx. And if you solve for dx, it's going to be du over 8x. Let's rewrite everything in terms of u. So we have negative 40x. Secant, instead of that angle, we're going to use u, and tangent of u, and instead of the x, we have du over 8x. Negative 40x divided by 8x is negative 5. And we have secant of u and tangent of u du. We said that integral of secant x times tangent x is secant x. So we have negative 5 secant of u plus c. And if you bring u back, you obtain negative 5 secant of 4x squared plus 5 plus c. Example 8. X e to the x squared. We have e to the power, so let's call this power our u. If u is x squared, then du will be 2x dx, the derivative of this. and then if you solve for the x, you obtain du over 2x. Let's rewrite everything in terms of u. We have x e to the u, and instead of the x, we have du over 2x. X's cancel out, and if you pull 2 in front of integral sign, which is going to be 1/2, because this is in the denominator, e to the u du. Integral of e to the u is e to the u. So we have 1/2 e to the u plus c, and if you bring u back, you obtain e to the x squared plus c. Example 9. In this example, we have 2e to the 10x on the numerator, and we have -3, two terms on the numerator, and we have e to the 2x as the common denominator for both. So we're going to rearrange this integral a little bit. So we can separate the terms. We have 2e to the 10x divided by e to the 2x minus 3 over e to the 2x, because this is common denominator for both terms, dx. Now we separated the integrals. Let's treat them separately. So we have integral. We can pull this 2 in front of integral sign, e to the 10x over e to the 2x dx, minus we have another integral that we can pull 3 in front of integrand sign, 1 over e to the 2x dx. And if you divide e to the 10x by e to the 2x, you obtain e to the 8x. 10x minus 2x is 8x. And if you bring e to the 2x on the numerator, it becomes e to the -2x, because whenever you move, the power changes the sign. Now we know how to integrate these. Now let's do u substitution here and there. Let u in this integral be 8x, then du will be 8 dx, and if you solve for dx, it's going to be du over 8. And in this integral, let u become -2x. Then du will be -2 dx, and if you solve for dx here, it will be du over -2 or du over 2. Now let's rewrite everything in terms of u. In the first integral, we have 2 integral e to the u instead of 8x, and instead of the x we have du over 8, minus we have integral of e to the u, and instead of the x we have negative, if you pull negative sign in front, du over 2. So this -2 negative we pull in front of integral sign, and we have another negative here, so negative times negative becomes positive. Now if we rewrite everything, we have 2 over 8, and antiderivative of e to the u is e to the u plus c. And here we have 3 over 2, and if you take the antiderivative of this, it's e to the u plus c. Now we need to bring u back. So in the first integral, we have 2 over 8, which is going to be 1/4 e to the 8x instead of the first u here, and then plus 3 over 2, and instead of u in the second integral, it was -2x, and plus c for all of them. So this is our final answer. Our last integral for this part is dx over x times 1 plus ln of x. So we have 1 plus ln of x in the parentheses in the denominator. Let this part call u. So if 1 plus ln of x is u, then du will be derivative of this. Derivative of constant is 0. Derivative of ln of x is 1 over x dx. And if you solve for dx here, it will be du times x, or x du. Let's rewrite everything in terms of u. Integral from 1 to e to the 5 dx over x times u, and instead of dx we're going to write x times du. So instead of the x, we're going to write x times du. X is cancelled out, so we have 1 over u du. So we have integral from 1 to e to the 5, 1 over u du. Antiderivative of 1 over u is ln of u. So we have ln of absolute value of u from 1 to e to the 5. This is definite integral, so we write the boundaries. Now we bring u back. Ln of our u is 1 plus ln of x, and from 1 to e to the 5. Now we're going to apply fundamental theorem of calculus. Upper boundary minus lower boundary. So we have ln of 1 plus ln of e to the 5 minus ln of 1 plus ln of 1 Now we know that ln of 1 equals to 0, and ln of e to the x is equal to x. So that means if you have ln of e to the some argument, it equals to that argument. So in our case we have ln of e to the 5, that's going to be equal to 5. So we have ln of 1 plus 5 is 6, minus ln of 1 plus 0 is 1, we have ln of 1 again, and ln of 1 is again 0, so our final answer is ln of 6. That was the end of the video. Thank you for watching.